Now we're going to get into the 8th grade version of everything, where we have multiple variables on one side. So we call these multi-step equations because there's more than just those one or two that we were doing from before. So real quick review of the vocabulary. Same words as the last set of notes when we were reviewing. Same vocabulary words. A math sentence with an equal sign is an equation. Equal sign, equation. They both start out with the same letters. That kind of helps me remember. A letter that represents a number is a variable. Opposite operations like addition and subtraction, multiplication and division. Remember, the word we want to use there is inverse. Opposite, inverse, they mean the same thing, but inverse is kind of like the math way to say it, a little bit fancier. To be alone. For this, we're talking about the variable. We're trying to get the variable alone. We want to isolate the variable. Multiplicative inverse, that's like I have the fraction 1/2, and I flip it so it becomes 2/1 is the reciprocal. The number in front of the variable, it's like my m, it's like my slope. Another word for that is coefficient. And the number by itself, the y-intercept, that b, that is my constant. Again, these words are really important. We need to be familiar with them because we're going to use them a lot during our lessons of this unit. Go ahead and pause that if you need to. Otherwise, I'm going to keep on keeping on. So first, we're going to review combining like terms. Reviewing combining like terms. Remember, like terms have the same variable and degree. Degree means exponent. But for the 8th grade version of this, we're not going to be seeing exponents. We're just going to focus on does the number have a variable or not. So I see here 4 does not have a variable. That one does. This one, -2, does not have a variable. They are like terms. Everything else has a variable. So that means that they are like terms. It's really important to remember this piece down here, this third bullet. The plus or the minus in front of the term goes with that number behind it. So this positive goes with the 3x. This negative goes with that 2. This negative goes with that x. This positive goes with that 5x. Because now that we've identified the like terms, we can combine them by adding them together. So here I have a 4 and a -2. So 4 plus -2 or 4 minus 2 equals 2. And then for all these teal ones, when I have multiple, it kind of helps me to line them up like you normally add or subtract. So here I have 3x minus x. We talked that there's like an invisible number that we write in there. That's really there, but we're lazy math people, we don't write it. Remember, they have invisible ones. There's really an invisible one there. So I really have 3x minus 1x, which is going to give me 2x's left. But then I also have to do this plus 5x. So I'm going to add another 5x. Again, I just keep the x and I add 2 plus 5 gives me 7. So all of that teal stuff gives me 7x. Now I need to rewrite this and put it together to make an expression. When I do that, when I rewrite all this business, a long time ago, mathematicians decided just so that everybody's on the same page, so that everybody follows the same rules, we write the numbers with the variable before the constants, before the numbers without. So 7 has a variable with it, so I'm going to write that first. So it's going to be 7x, and then I've got this 2. But I need an adding or subtracting symbol in the middle there. And to figure out if we're adding or subtracting, we need to look at what that number is. That's a positive 2, not negative. So because it's positive, we are adding. If that would have been a negative 2, we would have been subtracting. So you need to look at that number to see, am I supposed to be adding or subtracting there? So there's the first one. Go ahead and try this next one on your own. Pause the video, and see if you can combine those like terms on your own. Hopefully for this last one, you got 3x minus 8. X plus 9x gives me 10x. Minus 7x gives me 3x. And then this minus 8, there's no other like terms for it to combine with because everything else has a variable. So I bring down my 8, and I remember it's negative, so that's why I'm subtracting there. Let's go ahead and let's take combining like terms and apply it to solving an equation. We're still going to start off with drawing our river of love through the middle. Now, before I can go through and do sad Meg, I need to combine my like terms. I can only combine like terms on each side of my equal sign. So that 4 can't go with anything. I'm just looking at the stuff on the left that I can combine. What do you see there that I could combine on both sides? Yeah, I have a 2x and I have a plus 3x. What is 2x plus 3x? 5x. So I've got that 5x, and then I want to make sure I keep everything else with me. So I have minus 11 equals 4. There's nothing to combine that minus 11 with. It doesn't have a variable. So now that I've done my combining like terms, I can go through and I can do my sad Meg. Sad Meg. So first, my subtracting and adding. Remember, I want to use inverse operations to isolate my variable. So I need to save my coefficient, my variable, for the last. Inverse operation of minus 11 would be the opposite, which is adding 11 to both sides. I have to keep my equation balanced. And negative 11 plus 11 makes a 0 pair. They eliminate each other. So I'm going to bring down that 5x. 4 plus 11 is 15. Now, my dividing and multiplication. 5 and x side by side. Side by side means multiply. The inverse of multiplication then is, of course, division. So I have to divide both sides by 5. Multiplying and dividing by 5 eliminates each other. They're inverse operations. 15 divided by 5 is 3. Don't forget to bring down that x. And we see that x is equal to 3. I want to take a second and show you guys how you can check this on the calculator. So to check this on the calculator, the first thing I want to do is I want to tell my calculator that x is equal to 3. If you go where it says ABC, you'll see your alphabet. So you can find your x, tell it that it equals 3, and hit return. Then I need to plug in the long side of my equation. All this math that I did to this one side, I need to plug that into my equation, or to my calculator. So that's going to be 2x minus 11 plus 3x. Ooh, Andrea doesn't like that I did capital X's. There we go. And I see that that equation should equal 4. And that is also what I see up top, that it equals 4. So we are correct. Go us. So that was a problem where we were just doing combining like terms to solve our equations. Now we need to do the same thing but with the distributive property. If you forgot about the distributive property, remember that's when we have a number outside a set of parentheses. We have to multiply that number outside the parentheses times everything on the inside. Times everything on the inside. So for this first example, I need to take 4 times 3x. If I have 4 times 3, I get 12, and I keep my x's with it. That just means I have 12 x's total. Then I know I need to add the other number I'm multiplying. I'm taking 4 times a positive 2. Remember, that's a positive in front that needs to go with that 2. So 4 times a positive 2 gives me a positive 8. And that's why we're adding. If this was a negative number, we would be subtracting. But because when I multiply, I get a positive number, that means I'm going to add. And that's the distributive property. This one gets tricky because we have some negatives. We need to be careful with those. We talked earlier about those invisible ones. In this problem, if you ever see just a random, you think it's a minus sign, a random negative sign, remember that there's really an invisible 1 there. There's really an invisible 1 there. So that way, when I'm multiplying, I'm doing -1 times 9x. So that would give me a negative 9x. Then I need to multiply times everything on the inside. Now I need to do -1 times -8. That minus sign in front tells me that that's a -8 I'm multiplying. A negative times a negative gives me a positive. So -1 times -8 gives me a positive 8. And if y'all don't believe me, let's check our calculator. If I do -1 times -8, I get a positive 8. So there, I get -9x plus 8. Let's do some examples where we're doing the distributive property in solving our equations. So we're going to start off with the river of love. That's the thing we're best at. That's our favorite thing. We know we need to do the same thing to both sides, and we like having that reminder there. You guys are great about that. Now, I need to do the distributive property. I can't just start taking this 4 and moving it over here. I need to do that distributive property first. So I'm going to take 2 times 4, which is 8. Then I also need to do 2 times a positive 3x. What's that going to give me? Positive, because a positive times a positive is a positive, 6x. And then I need to keep everything else there too, equals 26. I need to rewrite my equation every step of the way. So there is the distributive property. Now, it looks like the way we're used to seeing it. I want to protect my coefficient, my variable, save that for last. I get rid of an 8 by doing what? The inverse, the opposite. That's a positive 8, so I need to subtract 8 from both sides. Bring down my 6x. What is 26 minus 8? 18. Use your calculator if you need to. No shame in the calculator game. Now we divide or multiply. Side by side means multiply. So the inverse, the opposite, would be to divide both sides by 6. 18 divided by 6 gives me 3. Again, I always want to be able to check my work on my calculator. I plug in the calculator the long side. So here I need to do 2 times 4 plus 3x. And I also need to tell it that x equals 3. So I tell my calculator here, x equals 3. And then I type in the other stuff. 2 parentheses 4 plus 3x. On my calculator, everything should equal 26, and that is exactly what I see up top. So we got this problem right. Go us. Pause that if you need to go back, rewatch it, write these things down. Otherwise, now we're going to do an example where we are doing combining like terms and the distributive property in one. We're going to have to do both of those things in one problem. So let's take a look at this. Ooh, I need to move myself in the corner over a little bit. My tummy's growling. All right, that's a lot. That's a lot, but that's all right. We got this. We're going to start off with our river of love because that's what we're best at. We know we need to make sure we're doing the same thing to both sides, and we like that reminder. Before I can start moving anything over here, before I can combine those terms, I first have to do the distributive property. We had some problems like this back in the first or the second quarter when we were learning this initially. So I hope you guys remember it. So I need to do the distributive property first. So I need to do 6 times 2, which is 12. And then I've got to do also 6 times that positive x. If there's no number in front, what's really there? That imaginary 1. So 6 times 1x is going to give me 6x. And it's positive, so I'm going to add that 6x, and then I need to bring down this minus 2x. So there is my distributive property. Now I can go through and I can combine my like terms. Oh wait, no I can't. I need to do equals 20. Come on, Andrea. I need to rewrite the equation every step of the way to make sure I don't lose anything. Now I can combine my like terms. What like terms do you see here? Remember, I can only combine like terms on each side. Yeah, I can combine that plus that positive 6x and minus 2x. What's 6x minus 2x? 4x. Then I need to make sure I'm rewriting this every step of the way. I've got that 20. I've got this 12. But should that be a positive or plus or minus in the middle? It should be a plus because that's a positive 4x. If it was negative, we would subtract, but that's a positive 4x. So we have combined our like terms. Now we can go through and keep solving with Sad Meg. So here I need to save, I need to protect my coefficient and my variable. I want to get rid of that constant. How do I get rid of that positive 12? Subtract 12 from both sides. So now I've got 4x is equal to 8. Divide or multiply. I'm going to divide both sides by 4. And I get that x is equal to 2. And if I check my work, on my calculator, x is 2. And I've got, oh boy, I have 6 parentheses, 2 plus x, close parentheses, minus 2x. On my calculator, I see 20. And on my paper, I see 20. So I'm good to go. There's a lot of steps here. Oh my goodness. There's so much going on. There's so many little things that we can get wrong. That's why it's important to show every single step of the way. That's why I like to use colors to help me see every single little step to make sure I didn't miss anything. This next one's a little tricky. This is like the hardest type of problem that you can see here. So let's see how we can do. Let's see how we can handle this. Always start out with drawing our river of love. Got to make sure we're doing the same thing to both sides. Then I know I've got the distributive property. I've got the distributive property that tells me I need to take what's on the outside of my parentheses and multiply it times what's on the inside. So let's use our calculator just to be safe. No shame in the calculator game. I have negative 1/2. Oh goodness. Negative 1/2. I arrow over. Negative 1/2 times, I'm just going to use parentheses. Negative 1/2 times 2. And I see that that is equal to negative 1. So there's my first part. I've got negative 1 there. Then I also need to take negative 1/2 times this other piece. It's a positive 4x. So I'm going to do again, negative 1/2, arrow over, times, I'm going to use my parentheses, 4. I can't do 4x. See, it doesn't recognize that. I can only do negative 1/2 times 4, and I get negative 2. So now I'm subtracting because that's negative. And then I've got my x. Then I have to bring everything else down. There's my gray. I have to bring down that minus x equals 3. There is my distributive property. Now I can combine my like terms. I see I have two numbers with x's in them, so I can combine those. I have a negative 2x minus x. What's that imaginary? Oh, y'all can't see that. What's that imaginary number that goes in front here? We have that imaginary 1, remember? So I keep my x. Negative 2 minus 1 gives me a negative 3. So now I have a negative 3x for those terms that I just combined. And then I need to make sure I'm keeping this minus 1 out front and that this all equals 3. Now we can get back into Sad Meg. I'm protecting my coefficient, my variable. I save that step for last. How do I get rid of a negative 1? The inverse would be to add 1 to both sides. They cancel each other out. I bring down that negative 3x. I haven't done anything there. 3 plus 1 is 4. There's that step. And then again, this next one's going to get a little tricky. Don't get scared. Side by side means multiply. The inverse of multiplication is division. So I divide 3 by both sides. Multiplying and dividing by negative 3, they cancel. So I have x equals, and now I pause. We talked last time about we don't want to see decimals. So if I put this in my calculator, if I do 4 divided by negative 3, that gives me negative 1.3 repeating. I don't want that answer. If I've got a decimal point, I want to leave it in fraction form. So now I need to think. Do I have a number that can divide into 4 and 3 evenly? Do they have a common factor? They do not. So that's my answer. I don't have to do any math there. I just leave it as negative 4/3. And that's it. That's my answer. It's an ugly number. It's an ugly number, but I don't have to do any real math with that last step. I just leave it in that fraction form. So here we're going to tell our calculator that x is equal to negative 4/3, and that ugly negative 1.3 repeating. And then I plug in what I started with. I need to plug in negative 1/2, parentheses 2 plus 4x, minus x, that piece right there that I started with. So negative 1/2, parentheses 2 plus 4x, close parentheses, minus x. On my calculator, on my calculator, I see I get 3. And in my original problem, I got 3. So we are good. Swish buckets. I know this was a really tough one, but like I said, it can't get much harder than having fractions and all these negatives in there. So nice job following me along with that. If you have questions, if you need more practice, let me know, and we'll keep on to the next part.